Let's talk about linear functions. Number one, determine whether the graph represents linear or nonlinear. Bro, this thing's linear because it's a line. And that's what linear functions are. If I could write more clearly, linear has this word line hidden in it. That is what's going on here. Determine whether this is linear or not. It's linear. It's a straight line like this. And I don't know if this one comes up later, but if it were a line like this, technically that is not linear because it would be, it would not be a linear function. It would be linear, but not a function, right? The vertical line test is what comes into play for functions. Is this a linear or nonlinear function? It's nonlinear because the rate of change changes. And if you're wondering what I was trying to draw right there, so like the rate of change there is that here it goes up, here it goes up even more, and in the future we can still plan on it going up, right? So it's a nonlinear function. It is a function, just not linear. Determine whether this represents a linear or nonlinear function. So x is going up by 2, by 2, by 2. Y is going up by 6, up by 2, up by 2. This is not a linear function. It would be linear if this were constant and this were constant. We need a constant rate of change on a linear function. Number 5, looks like we're going up 1, 1, 1. That's pretty straightforward. Down 15, down 15, down 15. This is a linear function with a rate of change or slope of negative 15. How can you tell whether a graph shows a discrete domain or a continuous domain? A graph will have a discrete domain if it's just made up of like points. I believe the right answer is individual points. And then a graph is continuous if it is a line or a curve. It's continuous. I mean, it's literally in the word. So describe and correct the error in determining whether the graph represents a linear function. The graph is a line. True. So I referred to this earlier, but it's not a linear function. A function passes the vertical line test. Well, this is all vertical, man. So it's not a function, okay? Determine whether the equation is a linear function, linear or nonlinear function. Is totally linear because we just have x with a 1 as an exponent. And if you're like, wait, what? That was something we kind of talked about in our notes, is that if we have y equals mx plus b, that is what every linear function will look like. But as soon as we throw in an exponent of some sort on our x, it's no longer linear, okay? So if there's an exponent, then we got a problem. Speaking of which, we're gonna have a problem here. When we distribute this 4x to simplify, we would get 32x minus 4x squared. Boom, this is a non-linear function. Number 10, determine whether the equation represents a linear or nonlinear function. Okay, definitely needs to be rearranged. Let's add x and add x, and we get, I'm gonna zoom out a little bit, y equals 3x minus 2/3 y. Let's add y, and we're gonna get 5/3 y equals 3x. And then when we divide by 5/3, yes. So this one's gonna be a linear function. And if you're like, wait, you didn't finish it. Yeah, I know I didn't. So here, y equals 3/5 times 3x, so y would equal 9/5 x. That's a function. Basically, I should have known up here that it was gonna be a linear function because it didn't mess with the exponents at all. But what I wanted to check was that it didn't like delete one of the variables, because like this, where'd it go? This line right here, this is the line x equals -3. That's not a function, right? And that's what we were kind of messing with over here, was determine whether it's a linear function. Well, I guess, you know what? It was gonna work out either way because your choices are it's either one or the other, right? So anyway, moving on. Okay, so now I'm realizing that something I told you in the notes is technically a little wrong, because something I told you in the notes is like, there was one example that was like y equals 1 over x, and this is what that graph looks like. It does something like that. And if we were to do the vertical line test on it, it's going to only touch in one spot each time. So it's like the unique input, unique output type thing. So really right here, I was about to be like, you know what, not a function. But then I thought, hang on, vertical line test. Because I was thinking not a function because x times y is going to mess with our exponent, but it doesn't actually. So watch this. I'm going to rearrange it. I'm going to subtract 2x. Okay, I get 3y equals 9xy minus 2x. I'm going to factor out the x. And I get 9y minus 2. I'm going to, let's see. I actually want to get y by itself. So maybe I'll start over, right? So why don't I instead move the 3y over? So 2x equals 9xy minus 3y. Yeah. And then when I factor out the y, I get 9x minus 3. I can divide both sides by 9x minus 3. And I get y equals 2x over 9x minus 3. So technically this thing works as a function. It's going to have this vertical asymptote, like I'd mentioned, and a vertical asymptote is like the function is undefined right here, meaning we'll never get that number, but vertical line test wise, it works perfectly. And if you're like, wait, not right there, it doesn't, that's just because my graph was kind of ugly looking. The real thing is it works. Okay. So writing compare discrete domains and continuous domains. Discrete domains are going to be like 1, 2, 3. So if we were to like discuss a domain for a discrete, here's domain, it would look like this, 1, 2, 3. It's literal numbers. I mean, this is also going to be literal numbers, but if it's continuous, the domain for that would be like x is a range. And you're like, what do you mean range? Well, so like what numbers fit in there for this statement? Does 2.1 work? Yes. Does 2.3 repeating work? Yes. So that's what's the difference between continuous and discrete. Determine whether the domain is discrete or continuous. Input time, hours, output of miles. Well, let's be honest. If you are driving, you don't just sit in the car for 3 hours and then you've gone 150 miles and then you sit there for the next 3 hours and all of a sudden you're 300 miles, right? This one has got to be continuous because that's how driving works. The time you cover is you're covering all the times in between. Like this is my fake graph, by the way. So that one has got to be continuous. Determine whether this is discrete or continuous. So you're on a relay team. If you have 0 teams, then you got 0 people. Cool. You have 1 team, 4 people. 2 teams, 8 people. This is definitely discrete because it's not like you can have 1.24 teams of, 5.8 people. That's just not how teams or people work. Let's model some real life. M equals 10 minus 1.44p represents the amount M in dollars of money that you have after printing P photographs. Okay, so all of this is the money after you print some photos. Okay, find the domain of the function. Well, it's got to be this. You will not be printing negative photos. You will not be printing all real numbers greater than 0. I mean, I guess Hang on. No, sorry. So it would not be all real numbers, because all real numbers, like 2.5 is a number, right? But you're not printing 2.5 photos. All whole numbers less than 100? I mean, no. I guess not. Here's why. You ready for here's why? Because we want to make money, right? And if we were to print even just 50 photos, what's going to happen here is 1.44 times 50 is going to be more than 10, and 10 minus 10 is 0. And we're in the business of making money here at Modeling Real Life Printing Photography Business. Is this domain discrete or continuous? It's discrete because, again, we're not going to be printing in parts of photographs, and we will not be making parts of money, so to speak. Graph the function using its domain. So over here we have dollars on the y-axis, dollars. That's all good. Photographs. Okay, that looks good too. It's not continuous. And let's see, what is the deal with these? There's only one teeny tiny difference, and it's that right there, as far as I can tell, that if we print nothing, then we have that amount in dollars. So it is that one right there. We're almost out of here. Modeling in real life, the linear function y equals 145 plus 30x represents the cost in dollars. So that function is the cost, because y equals that thing of an airline ticket after adding x checked bags. That x is bags. Okay. At most, 5 bags can be checked. So the domain of the function is, let's see, the set of all, so hang on, I was gonna choose this one, but it's got 6 right there. We can't have 6 bags, so it's not that one. All real numbers greater than 0, no, because we can't have more than 6. The set of all integers, that one threw me for a second, but it is between 0 and 5, so this is it. This is our answer right here, okay? And then all whole numbers less than 100, no, we can't have more than 5. Is the domain discrete or continuous? It's discrete because, again, we can only have like the price for 1 bag, 2 bags, 3 bags, etc., up to 6. We're not going to have a half a bag, right? Now they want us to graph this thing. So we, in our class, kind of know that has a y-intercept of 145 and a slope of 30. So we know a little bit more than perhaps we should. So really what that means is, like, right here at 145 we've got a dot. But also, if we were to just do the math, if I do 145 plus 0 bags, that's 145. If I do 145 plus 30 times 1 bag, that's 175. So right about here, I think, if we do 145 plus 30 times 2 bags, that's 205. Right about there. I'm going to run into my writing, so I'm going to erase some of my writing. And then we have 145 plus 30 times 3. That's 235. 235 is right about there. And you get the idea. We're just going to keep going up and over. We're going to go up 30 over 1. So let's see, at 235, we're up to 275, so it's like right there. Up another 30, 275, there'll be like 305, we're like right about there. So that is it. I shouldn't draw a line because remember, we don't have any information in between because we can't have halves of bags and such. So there it is, linear functions. See ya.